What's going on, guys? Welcome to Amigos Code. In this full course, I'm going to teach you exactly everything you need to know about Spring Security. I'm going to teach you how you are going to be able to secure your applications, right? Security is one of those topics that none of us has a clear and full understanding of how it works, but yet we need to secure our applications in one way or another. In this course, you are going to fully learn how to use Spring Security. You're going to learn about cross-site request forgery, roles, users and permissions, basic authentication, form-based authentication, and JWTs. And so that you know, there will be a lot to cover, but the good thing is we're simply going to focus on coding. I don't want to bombard you with the presentations because I don't think that's the right way for you to learn. Obviously, I've got some diagrams to show you exactly how things connect to each other, but we will code a lot in this course. So what I want from you is to go ahead and practice as I teach, because that's the best way for you to learn any new concept, framework, technology that you come across. If you get stuck, go ahead and drop me a message and I'll be more than happy to assist. If you haven't subscribed to my channel, go ahead and subscribe right now. Otherwise, let's go ahead and learn everything you need to know about Spring Security. Alright, for this course, you will get the source code for every single section at the end. So that means that if you are stuck, you can simply use a git checkout command and then the actual name of the section. And that way you can get the source code and follow along in case you get stuck, for example. And also, as I always say, make sure to practice as I teach, because that's the best way for you to learn anything. And without further ado, let's get started. All right, let's go ahead and kick off this course by navigating into start.spring.io. And in this website, we can bootstrap our Spring Boot application. So as you can see, this page has a Halloween theme, and this is because I'm recording this video just the day before Halloween. But if you watch it after Halloween, then you shouldn't see, the spider and the black theme. So you should see everything white. But I think this is really, really nice. So in this website, we can bootstrap the application. So go ahead and bootstrap this application with Maven, and then select Java, and then the version, pick anything above 2. So I'm going to pick the default, which is 2.2.0. Now for the group, leave it as it is, and then artifact, leave it as it is as well. You can change those according to your needs, but for now I'm going to leave them as they are. Then I'm going to click on options, and then right here you can see that you can pretty much just pick a Java version as well as the actual packaging. So for the Java version, I'm going to go ahead and pick Java 11 right here. So I haven't got Java 13 installed, that's why I'm picking 11. But if you have 13, go ahead and experiment, and I think it should just work. But for being safe, and if you want to follow along, go ahead and pick 11 or 8, and 12 as well will also work if you see that option. Next, right here, you can see that we can select a bunch of dependencies. So I'm going to click that, and you can see that we have a bunch of dependencies right here. So because we are learning about Spring Security, you can see right here, this is a dependency that we will need in a second. We have to choose this dependency, but not now. So I'm going to show you first how to spin up an application without security, and then we will manually install this dependency right here. So for now, what we need to pretty much just install is the Spring Web. So this allows us to build applications with Spring MVC using Apache Tomcat as a default embedded container. So go ahead and select that and then generate the project. Ooh, this is nice. I can see a ghost kind of like this. So I don't know if you'll have the chance to see this, but maybe not. But this is really, really cool. And I'm even scared right now. So I'm just going to generate the project. Now I'm going to open it up in my desktop. And if I collapse this, and now what I'm going to do is simply extract it and then delete this zip folder right here. And there we go. Now we have this demo folder. Next, let's go ahead and open up this folder with IntelliJ. For this course, the IDE that I'm going to use is IntelliJ. And if you want to learn more about IntelliJ, check out my website for this course, IntelliJ Developer Guide. And in this free course, I teach you everything you need to know about IntelliJ and why you should really use IntelliJ if you want to become a real software developer. Because IntelliJ allows you to write code really fast and you can focus on what matters instead of you wasting time with IDEs such as Eclipse or NetBeans. So go ahead and take this course and I highly suggest you. So you can watch this intro where I talk about exactly what IntelliJ is and why you should take it. So once you have IntelliJ installed, go ahead and click on open and then go to where the demo folder is and then open up the pom.xml and then as project and it's resolving the dependencies and there we go. So if I put this full screen, there we go. So now you can see that we have this folder right here called demo, and within this folder we have the pom.xml. So if I open it up right here, this simply contains the actual dependencies for our application. So remember that we selected this one right here, so Spring Boot Starter Web. So this is what we selected from Spring Initializer, and later on we're going to be adding the Spring Security, but for now I just want to show you how to get an application up and running without Spring Boot Security. Now if I close this and then open up source, main, and then Java, and then within this package we have demo application right here. So if I open it up, you can see that we have this main method right here. So also, if you want to learn about Spring Boot on my website, I've got this course right here which I highly recommend you taking, and in this course I teach you how to use Spring Boot. So it's the essential training, but I go over how to create controllers, how to create services, how to use dependency injection, how to switch implementations by implementing to an interface, and a bunch of other things. So I highly suggest you to take this course if you haven't used Spring Boot. If you have used Spring Boot, I've got this advanced course right here. So this is the full stack web development, and this is where we go in depth into databases, flyway migrations, connecting to real databases using Docker and Amazon AWS, build configurations, deploying it to real users, exceptions, implementing a user interface using React, and a bunch of other things. So I highly suggest you to take this course as well. And to be honest, this is what most students do take. So go ahead and enroll to either one of those courses in order to understand all of this if you haven't never done Spring Boot, or if you're not really familiar with Spring Boot. So right now, let's go ahead and simply run this main method. So let's go ahead and run the main method. And this just simply will ensure that everything is up and running fine. And you can see that right here. So we have no errors. And right here, you can see that Tomcat initialize it with port right here, 8080. This means that everything is working fine. And next, let's go ahead and build a controller or an API that clients can submit requests. All right, let's go ahead and build an API that will allow users to retrieve students. So let's go ahead and collapse this, and let's go ahead within the main package, create another package, and let's call this as student. And within that package, let's go ahead and create Java class, and let's name it as student and then controller. Now, I've got typo right here, so let me just fix that. So this should be con and then controller, just like that. And then let's annotate this class with at and then rest and then controller and then at and then request and then mapping. And right here, let's simply go ahead and say API /v1 and then students. And let's go ahead now and create a method. So right here, let's simply say public, and then this will return actually a student, and simply say get and then student right here. And what we're going to do here is simply pass the actual student ID. So let me go ahead and say integer and then student and then ID. And what we're going to do is the following. So this ID right here, we will get it from the path. So I want to say at and then get mapping. And then within the get mapping, I'm going to have a path. And then within this path, I'm going to add / and then student and then ID. Now, the way that I do get this student ID is simply by saying at and then path variable, and then the path variable that I want is student and then ID. So this student ID is this one, and in fact I don't need that /. Now we need to create this class right here called student. So I'm going to go to the main package and then create a class called student. And then right here, let's keep it super simple. So private final integer and then student and then ID. And let's also have a private final and then string student and then name. Let's add these to constructor. There we go. And let's have some getters just like that. And if I put this on a new line, and you can see that this model right here, so this class called student, contains the ID as well as the actual name. Now if I go back to student controller, you can see that the error went away. Now let me go ahead and simply have a private and then a static and then final, and then let's have a list right here. And within this list, I'm going to have students. And let me simply name this as students equals to arrays dot as list. And let's add few students. So new student, and let's add ID 1 and then James and then Bond. Let's have another student. So new and then student ID 2. Oops, not string. This must be an integer. And then this will be Maria and then Jones. And let's add a final student right here. So new and then student and then Anna. Oops, so this would be 3 actually. And then Anna and then Smith, just like that. So we have 3 students right here. So what we're going to do right here is simply say return. So let's simply say return and then students and then dot and then stream. So we're going to stream and then dot and then filter. and we have the student right here. And then what we're going to do is we're going to get the actual student ID, so the one that we get from the client, dot, and then equals, and then the actual student dot, and then get ID. So if this is the case, I'm going to say dot find first, otherwise, so or, and then else, I'm going to throw. So right here you can pretty much just throw a custom exception, but for now let me simply say illegal, and then state exception, and then student, and then plus student ID. Let me put this full screen so you can see exactly, and then plus does not exist. There we go. So this is using some streams, and also if you want to learn more about streams, go ahead and check my website for learning how to use Java streams. So now what we're going to do is let's go ahead and restart the application. So I'm going to stop and rerun, and this should be 3 right here. So Anna Smith. So now if I open up my web browser, and then if I go to localhost 8080, and then API v1, and then students, and then / and then 1, you can see that we have student ID, and then this is James Bond. Now if I do student and then 2, you can see that we have Maria Jones. So this is all for now, and if you have had troubles getting this far, go ahead and drop me a message. But now we have an API that we can start securing with Spring Boot security. Let's go ahead and add Spring security into our project and start securing things. So let's go back to IntelliJ and go ahead and open up the pom.xml. So inside of this pom.xml, this is where we're going to add the Spring security. Now go ahead and simply add a new dependency, and for the artifact, go ahead and simply say Spring dash and then boot dash starter, and then dash, guess what, security. There we go. And this will come from org.springboot, just like this one right here, and then enable auto imports, and there you go. So now let's go ahead and restart the application. Now let's go back to our API. And remember, before we had this endpoint right here, which gave us Maria Jones. Now, if I go ahead and refresh this page, you can see that. So if I put this smaller, you can see that we have this form right here. And to be honest, we didn't have to do anything. So the only thing that we did was to add the Spring Boot security dependency, and then we get this form-based authentication right here, right out of the box. And this is the reason why Spring Boot security is awesome. So you can see that we did only added the security dependency, and then without having to configure anything, we have form-based authentication, and this is really, really cool. So we have username and password right here. So the way that we get the password is from the console. So right here, you should see that we have this using generated security password. So go ahead and grab this, Command C, go back, and then right here, go ahead and simply say user as the username. And then the password is the one that we've copied from the console. I'm going to paste that in. Now go ahead and sign in. And you can see that now we get the original payload that we were expecting. And this is because now we are signed in. So Spring Boot, it's already doing the security work for us without us having to do anything. And this is really, really awesome. Next, let's go ahead and learn how to use basic authentication with Spring Boot security. Alright, so we've installed Spring Security and we have this form right here. So we didn't implement any of this, and this is pretty much what Spring Boot Security gives us right out of the box. Now, what you are seeing here is form-based authentication. So this is used widely throughout the internet, and you've seen many websites that allow you to sign in by simply using your username and password. So right here you can see that we can provide the username and then the password. So right here you can see that Spring Boot generates a random password, and I'm going to show you exactly how we're going to create users, set passwords. But for now, I just want to teach you and also give you an overview of form-based authentication before we move on. So I'm going to copy this password, and then the default user is user, and then paste the actual password. So what I'm going to do is actually, before I submit the request, I'm going to inspect on the console, and right here go to network, and I'm going to sign in. So you can see that we have the payload. So this is the actual JSON blob that we saw previously, right? So this is Maria, and if I do 1, we've got James Bond, and if I do 2, we have Maria, actually 3. So 3, we have Anna Smith. So currently we are logged in, right? So the actual original request was / and then login, right? So if I try that again, you can see that I go back to the sign in page, or actually login page, and we didn't implement none of this. So currently we're still logged in, and if I go back, you can see that this still works, right? So if I want to log out, so if I want to kill this session, I can simply go to the actual root URL and then simply type log and then out. And you can see that it says, are you sure? And I'm going to log out. And you can see that you have been signed out. Now, if I try to access the API, so API and then v1 /students / and then 1, you can see that I need to log in again. So let's log in once more. So user and then the password right here. And what I'm going to do is right here, you can see on the right hand side. So I've got the inspect panel open, and under network, you can see all the requests which are being made. So what I'm going to do now is simply sign in. And right here, you can see that we have this login request. So I'm going to click on it, and you can see that we have some details about the request that we sent to our server. So you can see that this was a post, the status code, and some response headers, request headers. But what I want to show you really is the actual payload which is sent to our backend. So you can see that the username is user and then the password. And also you have this CSRF, which I'm going to explain you later what it is. But for now, this is what gets sent to our backend. And we haven't configured anything. And Spring Boot Security handles everything. So it makes sure that the user exists, it checks the password, and if all of those conditions are met, then we can log in. So I just want you to realize the power of Spring Boot Security. It's really awesome, and you should definitely use it in your own projects. So form-based authentication is what you see all over the internet, but we also have other forms of authentication. So in this course, we're going to cover basic auth, and then I'm going to show you exactly in detail the form-based authentication. So this one right here that you are looking at. So if I say log out, So you can see that this is the form-based authentication. We're going to cover this much more in detail later on. And then towards the end of this course, I'm going to show you exactly how to use JWTs or JWTs. So this was a quick overview of form-based authentication. Next, let's go ahead and learn about basic authentication. But as I said, later on, we're going to learn more about form-based authentication with Spring Boot Security. All right, let's go ahead and learn about how basic authentication, or simply basic auth, works. So this is widely used as well, but there are some limitations between basic auth and form-based authentications and JWTs. But I want to teach you first basic auth because it's the simplest of all, and then show you exactly how form-based works, and then JWT, which is a really nice alternative instead of basic or form-based authentication. So with basic auth, you have the client right here, and the client wants to access some requests on a server, right? So it wants to issue, either a GET request, put, deletes, so on and so forth. So what the client initially does, and the client can be pretty much anything, right? It could be a web app, it could be your backend calling another API, or it could be an Android or iOS app. It could literally be anything. So what the client does is the client sends a request, right? So let's say that a client wants to view some data and then sends a request. Well, with basic auth, if you just send a request, you will get a 401 status code, meaning unauthorized from the server. And this is because with basic auth, you need to specify the username and password inside of the request header as base64. So every single request that you send to the server, you need to specify the username and password. And this is encoded as base64 inside of the request header. Then the server does some validations, whether the username exists. If the username exists, checks the password, and then if the password matches the one that the server knows about, then it sends a 200 status code with whatever the client has requested. So as you can see, this is very simple to understand, and to be honest, a lot of people still use it for accessing APIs. Not so much, for example, if you have to have a form on your website where people log in providing the username and password, because right here you can see that the client has to send every single time the password. And if you have a modern application, you don't want the user, for example, right here in this web app, for example, you don't want the user to send the username and password for every single request, right? So this is usually good when you are accessing external APIs. So let's go ahead and learn exactly how to implement basic auth with Spring Boot. Let's go ahead and change from form-based authentication to basic auth, where we have to specify the username and password for every single request. So I'm going to go back to IntelliJ. And what I'm going to do here is I'm going to collapse this. And right here, let's go ahead and create a new package. And right here, I'm going to call this as security. So this will be the security package. And inside, let's go ahead and create a new class. And I'm going to call this as application security and then config. So this class has to be annotated with @ and then configuration. And then we have to annotate as well with @ and then enable and then web security. So by doing this, this will be the place where we will configure everything that has to do with security for our application. Now, right here, we need to extend a class, and we have to extend web security configure adapter. So right here, you see that we've just extended this class, And if I press Control and then O, or actually Command O, you can see that we can override few methods right here. And to be honest, there are not many, but we can override some methods. So the one that I'm going to teach you first is this one right here. So configure. Configure, and this one takes the HTTP security. So select that one and then simply say OK. And right here, this is how we're going to secure things. So instead of super, go ahead and delete this line. Now inside, I'm going to use this HTTP right here, and I'm going to say HTTP, and then right here I'm going to press enter and then simply say dot, and then I want to authorize requests followed by dot any request must be authenticated. And then right here I'm going to say that and I want to use basic authentication, so this is HTTP and then basic, and there we go. So this is our new configuration. So right here we are saying that we want to authorize requests. Any requests must be authenticated, i.e. the client must specify the username and password, and the mechanism that we want to enforce the authenticity of a client is by using basic authentication. So HTTP basic. So let's go ahead and restart the server and give that a go. So I'm going to restart the server. And right here, you can see that we have this password, and then go back to my web page. And right here before, remember, we had by default form-based authentication. Now what I'm going to do is simply reload this page, and you can see that now we have this pop-up right here. And this is what exactly is basic auth from a web browser. So again, let's go ahead and pretty much just enter the username as user and then the password, so the one that I've just copied, and then sign in. And you can see that this application has no explicit mapping for /. So basically right here, what I need is to go to API and then v1 students, and then I want to get number 2. And you can see that now I do have Maria Jones. So you can see that it is really straightforward. Basic authentication. It's very simple to use. You just need the username and password, and that's it. Now, one of the drawbacks of basic auth is that you can't log out. So I can't simply, go here and then simply say log and then out. So there is no way for you to log out. You can see that we have a white label error page. So there is no way for you to log out because the username and password is sent on every single request, right? And for every single request, the server has to validate whether the username and password is correct. So this is pretty much how you use basic auth. So let me actually go back to the API, and basically within the browser we get this pop-up. So in fact, let me go ahead and restart the server so you can see the pop-up once more. So if I refresh, you can see that this is the actual pop-up. So next, let me go ahead and show you exactly how to use, for example, a client where you're going to be able to specify the username and password inside of the request headers. Alright, for this part of this video, go ahead and download Postman, and Postman allows us to test our APIs. So because we don't have, for example, a mobile client or a web client, we can trigger requests as if we were using some of those clients. So it's pretty much really useful to test your stuff locally before you send it to an environment where real applications or clients use it. So once you have Postman installed, go ahead and open it up, And right here, you can see that in this user interface, we can issue some requests. So right here, you can see that we can issue get, post, put, delete, copy, and some other request types. So right here, we're going to send. So let me actually show you. So remember, so right here, if I put this on the foreground, so like that. So before we were using the web browser, and by default, the web browser shows you this model right here where you have to specify the username and password. So right here, you can see that it's actually spinning until we provide the username and password. So often, this is not a great user interface. So every time you want to access a resource, you have to enter your username and password. So what you would do is within the actual request, right? So if you are using, for example, an Android application or a React or an iOS app, you simply bake the username and password inside of the request headers. So right here, go ahead and select get. And we're going to issue an HTTP request to local and then host 8080/API/v1 and then students and then /2. So right here, I'm going to send this request and you should guess what's going to happen. So right here, you can see that I'm not authorized. So you can see that this 401 request is what I've showed you before, right? So this is the 401 request returned by the server. So now let's go ahead and add the username and password inside of the request header. So right here, go ahead and you can see that the type, so right here, no auth, go ahead and select basic auth. So now go ahead and say user, and then for the password, if I open up IntelliJ, you can see that this is the password. Grab that, go back and then paste that in, and I can go ahead and simply send the request, and you can see that this time we do get our JSON payload right here. So what I want to show you actually is the actual headers. So go to headers, and right here you can see that the headers includes the authorization right here, and then basic, and then right here. So this right here is a username and password as base64. So remember, so right here I said base64 username and password. So if you have any questions on this, go ahead and drop me a message. Next, let me go ahead and show you how you're going to whitelist some URL paths using Ant Matchers. All right, let me go ahead and show you exactly how you're going to be able to whitelist some URLs with security. So right here, we simply have to provide the username and password. So let me go ahead and simply say user and then password. So right here, oh, actually, I need to get it from here. Just like that. Go back, user, and then paste the password. And you can see that I'm in. So there are times that you might have, for example, an index.html right here, and you want this to be public. So currently we have like 404, meaning that there is nothing to be served right here. So let me actually go back to IntelliJ, and if I open up the project tab, open up resources, and inside of static, go ahead and create a new file. Simply say index.html, and then simply say h1, and then simply say hello, spring, and then boot security. And if I restart the server, and then right here, so if I get this, and then right here, so if I refresh, so let me actually say user, and then the password, sign in, and you can see that we have hello Spring Boot security. So let's say that this is the actual, main page that you want to whitelist for every single user. So every single user whether they are logged in or not, they should be able to get access to this page instead of having to enter their username and password. So it's what happened, right? So if I restart the server, so right here, so if I refresh this, you can see that I have to enter my username and password. So the way that we can whitelist, specific URLs with Spring Security is if I go back to IntelliJ and open up the application security config. So right here, so if I collapse this, so right here, we can simply say after authorized requests, say .ant and then matchers. And then within ant matchers, we can specify some patterns. So right here, I can say that, for example, I want to allow, requests going to the root as well as the index. So anything that has an index will be whitelisted. I can also whitelist some CSS, right? So go ahead and say /CSS/ and then any CSS, and the same with JavaScript. So /JS/ and then star. Now we have an error, and that is because we need to say these patterns right here, we want to permit. So dot and then permit all. Now, if I restart the server and go back to my web browser, if I cancel out of this and now reload the page, you can see that I don't have to specify the username and password. Again, if I reload, you can see that I don't need to specify the credentials. Now, as soon as I try to access API and then v1 and then students and then 2, enter, you can see that now I have to specify the username and password. So let me actually grab the password, go back, and then user, paste the password, and you can see that now I can access this URL. So this is how you pretty much whitelist some URLs. So if you have any questions on this, go ahead and drop me a message. Next, let me go ahead and show you how to create users with a predefined username and password. In this section, let's go ahead and learn about users. So currently, when we start our backend, Spring Boot Security gives us a default user, which the username is user, and then the password is this random user. And this user right here, it's stored inside of an in-memory database. So let me show you again if you don't remember. So right here, if I start the application, there we go. You can see that using generated security password, and this is a random UID. So this is this default user. Now, obviously, when you develop your own applications, you want to have a bunch of users, i.e. users signing up to your application so that you can then authenticate them as you need. So usually we would have something like this. So you'd have a bunch of users, and then you'd actually store them inside of a real database. So in this case right here, you can see that it's a Postgres database. And if you want to learn more about Postgres and SQL, go ahead and check my website for a course where I teach all of this for free. So the idea is that you have a bunch of users, and then you want to store them inside of a database. So right here, you can see that whenever we restart the server, we lose this user's password. So with a real database, that won't be the case anymore. So with users, there are a few things that we need to learn about users. So one is that a user must have a username, and this username must be unique. And then it must have a password. The password must be encoded because we don't want to be storing passwords as plain text, because that's a really bad idea. And then with users, you can define roles, and this is how you're going to control what endpoints they should be allowed and what they can perform inside of those endpoints using authorities. So this is optional, but it's highly recommended that you use authorities. But we're going to learn about this roles and authorities throughout this course in detail, and a bunch of other things that I'm going to show you later in this course. So for now, let's go ahead and create a user. So we're going to create a user, and then we're going to define the actual username and password and still use an in-memory database. But obviously I'm going to show you how to store users into a real database. Next, let's go ahead and create a user. Alright, so to create our very first user, let's go ahead and override one method. So I'm going to press Command O, and the method that I want you to override is this one right here, user details service. So right here, after override, go ahead and simply say add and then bean. So this will be instantiated for us. And if I put this full screen, so this user details service is how you retrieve your users from your database. So right here, I'm going to simply define a user, but ideally what we will do later is to retrieve a user from the database. So right here, let me actually go ahead and remove this return super user details service. And what I'm going to do here is simply say user and make sure to pick the one from Spring Framework, and then dot and then builder, and then go ahead and simply say username. So let's define the actual username. So this will be Anna and then Smith, just like that. And then the password, dot and then password. So go ahead and simply say password. And then finally, go ahead and specify roles. So right here, let's go ahead and simply define one role, and the role will be student. So she is a student. So this is Anna Smith right here. So now let me go ahead and extract this to a variable, and you can see that I do have a user right here. So user, or actually Anna and then Smith user, just like that. Now what I'm going to do is actually click on user details service, and you can see that this is an interface. So right here you can see that I can see which classes do implement this interface. So if I click on it, you can see that I do have caching user details service, in-memory details manager, JDBC DAO implement, and then user detail manager, and so on and so forth. So the one that we are going to use is this one right here, in-memory details manager. So if I go back, and right here, let's go ahead and simply say return new in-memory details manager. And this takes, you can see that it takes a collection of users or a series of users. So right here, let's simply go ahead and say Anna, or actually Anna and then Smith user. And you can see that we have an error, and this is because we are using a builder right here, and we need to say dot and then build. And you can see that now this is no longer this builder, right? So if I remove that, so let me actually grab this name, and that shouldn't be a builder. So if I refactor this, Anna Smith and then user. So there we go. So now you can see that we have this username, Anna Smith, the password is password, and then student is the actual role. So roles and then student. And this internally will be role underscore and then student, just like that. So this is how Spring Security understands this student and then uses throughout the application for accessing some resources, which I'm going to show you exactly how to use it. And then we build it, and then we have this user details. So let me go back to the actual diagram. So right here, remember I said that the password must be encoded. So if we try and run this, and then let's go ahead and try and access this API, Anna, and then Smith, and then the password is password, sign in. You can see that that didn't work. If I go back to IntelliJ, you can see that we have an error, and you can see that there is no password encoder. And that's what we're going to learn next. Alright, so let's go ahead and define the password encoder that can be used for encoding this password right here. So let me collapse this and then expand the tab, and right here inside of the security package, let's go ahead and create a new class and simply say password and then config. So right here, annotate this with @ and then configuration, and we're going to create a public and then password and then encoder, and simply name this as password encoder. So right here, this password encoder, so this is an interface, and this interface has 3 methods. So encode, so this takes a series of characters and then encodes the password into a random character, and then we have the matches, right? And then we have Boolean upgrade encoding. So this is actually what we are interested, right? So this encode right here, and this is what Spring Boot Security uses internally to encode the passwords. So the most famous password encoder, and you can see that this is an interface right here. So the most famous password encoder out there is this one. So I'm going to say return and then B and then crypt password encoder. And obviously I need to say new, and right here we can specify the strength inside of the constructor. So I'm going to choose 10 right here. So this is the strength on how to encode the passwords. So there we go. So I'm going to leave a link on bcrypt so you can go ahead and read more about it, but this is the most popular password encoder out there. Now let's go ahead and simply annotate this with @ and then bin. There we go. Now let's go back to application security config, and inside of the constructor, so let's go ahead and simply say private final and then password encoder. There we go. And let's auto wire. So we're going to auto wire this guy. So this password encoder will be this one right here. So let me actually open up password config, will be this one, which is bcrypt. Now this solves the problem. So actually this is not doing anything just yet. So let me comment that out. So if I restart the server, there we go. If I now try and access right here, so Anna Smith and then password, sign in, you can see that this didn't work. And if I go back, you can see that we have a message right here. So log line saying encoded password does not look like bcrypt. So this is why I wanted to inject the password encoder right here. So if I uncomment that, now when I define the password, I can go ahead and simply say password encoder dot and then encode and then the actual password. Now if I restart the server, there we go. If I go back to Chrome and Anna and then Smith and then password, and then sign in. You can see that it works. Now just let me reload the page so you can see that it's working. And there we go. We've successfully managed to encode our passwords. So just to show you exactly what this password looks like, so if I put breakpoint right here and stop this, and then pretty much just run this in debug mode. There we go. Now I'm going to press this evaluate expression. So password encoder dot encode, and then simply say password inside, and then evaluate. You can see that now the password looks like this. So this is the random sequence, which makes it really hard for an attacker to know that this random sequence right here is password. So this is the actual password right here, right? So make sure to always use a password encoder. And to be honest, like Spring Boot Security won't let you proceed because it wants you to follow the right patterns to secure your applications. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. Alright, it's time for us to learn about roles and authorities, or simply permissions. So I think permissions is the better way instead of using authorities. So a role is simply a high-level view of all the users that you have in your system. So the idea is that for a specific user, you assign a role. So the role is just the high level view, and then you have authorities or permissions. So you'll see a lot of people say that this as authorities, but I think that this should be permissions because it's easy for you to reason about. So let me show you the actual diagram, and this will make complete sense to you. So right here, you can see that I do have a role called admin. And then these ones right here, so student column read, courses write, student write, and courses read, these are the permissions. So you can see that the role is the high level view, and then within a role you have a set of permissions that a role has. So right here, so let me show you. So right here, so you can see that if I make this smaller, so right here you can see that these are the permissions. So these ones, course write, read, student write, and student read. So these are permissions. And then admin, so the higher level is the actual role. And create another role called student. So right here, and currently we have a role assigned to our student, but right here you can see that the student, so the student role doesn't have courses write. So a student may be able to view the student information. It might be able to update its details, and also it might be the list of available courses in your system. But what a student cannot do is to update course information, because that's really an admin job. So you can see that within this role student, it doesn't have the capability to modify courses. And this brings us to the point of how we use roles within our system. Well, it's very straightforward. So these roles and permissions allows us to secure our APIs. So for example, you might have an API which only can be accessible by admins, or you may have an API which might be only accessible by students. So let's go ahead and actually create a second user. So we're going to create an admin user and then secure some APIs. Alright, so right within IntelliJ, right here inside of our user detail service, let's go ahead and create another user. So simply use the user and then dot and then builder and username. So let's give this as Linda, and the password. So let's define a password. For now, let's simply use password encoder.encode, and let's go ahead and simply say password 123. So obviously your users will have a much stronger password than these ones, and you also should enforce a strong password for your users to better protect your applications. So now let's go ahead and simply say dot and then roles, and then for the roles, let's go ahead and simply say that she's an admin, just like that, and then dot build. There we go. Extract this to a variable, Linda, and then user. And finally, what we need to do is simply pass Linda right here. So Linda and then user. So there we go. Now we have a student right here, which has a role of student. And then we have Linda, which has a role of admin. So right here, so you can see that we have this role admin, and then we also have this one right here, student. Next, let's go ahead and refactor things a bit so that we can have these authorities, so right here, or simply permissions. So far we have two users. We have Anna Smith and we have Linda. Anna Smith, she is a student, so she's got the role of student, and Linda, she's got a role of admin. So previously I said that we can attach permissions to roles, and in this scenario you can see that this student right here has a set of permissions, and the same for the role admin. So this role right here has some set of permissions. So the cool thing about permissions and roles, or actually roles, is that you can assign more than one role to a user, right? So let's say that while she's a student, she also works for, the university, and she also becomes an admin. So you can do that this way. So you can assign multiple roles to a user. So we're not doing this just yet, but just so you know that you can do it. So right here also you can see that this student right here has a set of permissions. So I think that in our model we're not going to attach any permission to a student. So let's go ahead and remove this, and I think this is what we're going to go with for now. And if we need to make changes, will be very trivial because they will follow the same interface. Now let's go back to IntelliJ, and right here remember that we have this user right here. So this is Anna Smith, she's a student, and we also have Linda right here, and she's an admin. So let's go ahead and define an enum that will represent roles in our application. So go back to IntelliJ, and inside of the security package, create a new class, and right here simply say application, and then user, and then role, and this will be an enum. And right here let's define student and also admin, just like that. Now you can see that we can attach 0 or more permissions to a role. So let's also model that with an enum. So go ahead and create new enum. So right here enum, and this time go ahead and simply name it as application, user, and then permission, just like that, and then press enter. And I've got a typo, just let me fix that, just like that, and I'm good to go. Now let's go ahead and inside here, so previously I've showed you the set of permissions, but let me actually show you again. So if I go back to the diagrams, and right here you can see that this role admin has 4 permissions. So student read, courses write, student write, and courses read. And previously I've showed you that a student can have also some permissions, but we're not going with this model right here for now, but we will implement it with admin. So right here admin will have 4 permissions. So you can see that the way we define these is student and then column read. And to be honest, this is subjective, how you want to implement the permissions, right? How you want to use them throughout your code base. But in my opinion, I think this is a very nice way where you define the model, and then what the actual permission. So whether it's read or write. Read means that you can only read, and write means that you can, for example, you can insert a new object, you can delete, and basically you have more privileges, right? So let's go ahead and define these with our enum. So right here, let's go ahead and define student and then read, and inside we will represent this as student column and then read. Let's do the same for student write, student and then write. The same with course and then read. And finally course underscore write, and this will be course and this column actually, and then write. There we go. Now we have an error, and that's because we need to define private final, and then this will be a string permission. There we go. And let's add this to constructor and then refactor, and I've got a typo right here in permission, so let me actually rename all of that. So there we go. So also let's define a getter, and you can see that now we have a set of permissions. Now let's actually, so right here, so we're going to attach the permissions to a row. So in our previous example, so actually here, we said that a role can have 0 or many permissions. So let's go ahead and model that. So what I'm going to do is actually add a new dependency. So open up pom.xml, and after Spring Boot Starter Security, go ahead and add a new dependency, and right here simply say com dot and then google dot and then guava. And for the artifact, simply say guava. And then for the version, so we need to define a version right here, just like that, and then simply say 28, so 28, and then .1 and then -Jerry. So this will just give us some helper methods that will be really useful. Now go back to the actual application user role, and right here what we're going to do is actually define the actual permissions. So private and then final, and this will be a set because they must be unique. And right here simply say application user and then permission, and then simply say permissions. Add this to constructor just like that, and there we go. So now for a student, remember we said no permissions. So right here what I'm going to do is simply say sets dot new hash set, and this will be empty, and you can see that this is guava. Now for the admin, go ahead and simply say sets dot and then new hash set, and right here remember we said we will have all these 4 permissions: student read, write, student, student read and write, and course write and read. So let's go ahead and add those inside of this set. So application user, and then right here, so let me actually have a static import for this. There we go. And now I can say course read and then course write, and then we'll have student read, and finally student and then write. And there we go. So we've actually managed to model all of this with enums. So let me actually go ahead and have the actual getter right here, so for getting the actual set of permissions. And yeah, so we actually have this student role right here, right? And we have admin, so admin has 4 permissions and student has 0 permissions. Next, let's go ahead and attach these to our users. So open up the application security config, and right here, so roles for Anna Smith, let's actually use the enum, right? So application user role dot, and then she's a student dot and then name, and let's have a static import right here, And let's do the same for admin right here. So admin, or actually application user role dot and then admin dot name, and this will be a static import as well. And there we go. Next, let's go ahead and learn exactly how we are going to use roles to secure API endpoints. So this one right here, API v1 / students. All right, let's go ahead and secure this API resource right here to only be allowed by students. So go ahead and start your server. So we've had a couple of changes, and just to make sure everything is working fine, you can see that we have no errors. Now go ahead and open up Postman, and right here let's go ahead and hit this endpoint localhost 8080 API v1 students, and then let's get student 2. So right here, the username, let's go ahead and use Anna and then Smith, and the password was password. So let me actually show. And for the authorization type, select basic auth. So right here, so we are using still basic auth right here. So with that in place, go ahead and simply send the request, and you can see that we have Maria Jones. So also I can go ahead and change this to 3, and now we get Anna Smith profile. So she's the user Anna Smith, and she can access this resource right here and get her profile. Now this API is only meant to be used by students. So if I go ahead and change this to Linda and then password 1 2 3, so right here, so password 1 2 3 for Linda, and then send, you can see that Linda also can access this resource. So we shouldn't be mixing resources which are meant only for students and resources which are meant only for admins. Resources meaning APIs, right? So if you want to have an API specific for admin users, then you should be creating a separate resource. For example, admin and then / and then v1, something like that, right? So currently Linda can access this API, but we don't want to allow that. So let's go ahead and pretty much protect this API with role-based authentication. So let's go back to IntelliJ, and if I scroll to the top and also put this full screen. So right here, you can see that the first thing that we are doing inside of this configure method is to authorize requests, and then we are using ant matchers. So here what we are saying is for these patterns, we are going to permit all. So let me put this on the same line. Next, we can go ahead and define a second ant matcher, and right here I'm going to say /API /*, and this will match. So this will match this. So /API and then anything, right? So let me go back. So right here, what I'm going to do is for this pattern right here, I'm going to say dot and then has role. So you can see there has role, and the role that we want is not that one. Oops. So if I delete that, so we want application user role dot and then student dot and then name. So this takes a string. So oops, that shouldn't end with semicolon. And now you can see that this ant matcher will protect this API. So anything that has to do with API for students to be accessed by students right here. So with the role of student. So basically as it stands, so if I show you the diagram, so Anna Smith and Linda can both access the API right here. So what we want to do is to remove Linda from accessing this API and only Anna Smith. So let's now go ahead and test this. So if I restart the server, there we go. And if I open up Postman, so previously you can see that Linda was able to access this API. Now, if I send the same request, you can see that now she's getting a 403 status code and the error is forbidden. So we are using role-based authentication to protect our APIs. So if I now change this from Linda to Anna and then Smith, and the password is just password, send, you can see that Anna can access this API. So we still have another issue to tackle later on, and that is Anna at the moment, she can access, for example, Maria Jones and also James Bond details, right? And we only want to allow her to access her details, but we will tackle this later on. But for now, you can see that we are using role-based authentication to protect our API. So right here, so only Anna Smith with role student is able to access this API, and Linda, she's forbidden from accessing. And this is the power of role-based authentication. So we've covered role-based authentication, but we also can use permission-based authentication, right? So right here we have a set of permissions, and we can also say that you are only allowed to access this resource if you have this permission. And that's what we're going to learn next. All right, so previously we protected our API with role-based authentication. Now let's go ahead and focus on permission-based authentication. So right here, so this is what we've done previously. Now we will focus on this part right here. So this is, so if I get this right, so this is permission-based authentication. So currently we have this role admin and it's assigned to Linda. And we are going to create a second role called admin trainee. And basically they will be able to access this API right here. So management /API v1 and then students. So the difference here is that Linda, she will be able to read and write on this API, but Tom, because he's a trainee, he will only be able to read students from this API. So let's go ahead and first create the user and then define the actual API. So go back to IntelliJ, and right here, let's go ahead and duplicate this. And this will be Tom. So Tom user, this will be Tom. The password, you can leave it as password 123. And then right here, so instead of admin, let's go ahead and create a second row. And let me have a comma right here. And right here, this will be admin and then tray and then knee. So right here in the actual permissions, so we said that Tom will only be able to read from this API. So right here, let's go ahead and remove the student write and also course and then write. There we go. So as you can see, this role right here, admin trainee, doesn't have as many permissions as someone which has this role called admin. So let's go back to the actual configuration, and right here let's simply say admin and then trainee. So this is Tom, and basically this will be this. So I'm going to explain this in a second, why I put role underscore and then admin trainee in a second. So finally, let's go ahead and simply pass Tom right here. So Tom user, and there we go. Next, let's go ahead and define this API right here. So management /API v1 and then students. All right, so within IntelliJ, let's go ahead and inside the student package, create a new class. And right here, simply call it student management and then controller. And right here, let's go ahead and open up student controller. So we're going to steal some code. So let's grab all of this, go back, paste that in. And right here, instead of API v1 students, this will be management / API v1 and then students. Now let's go ahead and go back to student controller. And for now, let's simply grab this list right here, and we're going to refactor things later on. But for now, let's just go ahead and keep things simple and paste the exact same list right here. Now let's go ahead and define 4 methods that both Linda and Tom will be able to access. But obviously Linda will be able to access more resources or more APIs than Tom, because Tom only has the read privilege or read permission. So right here, let's go ahead and first define a method to get all students. So public and then list, and this will be student, and then get all and then students. And right here, let's simply go ahead and return students. There we go. Next, let's go ahead and define another method. So public and then void, and this will insert a new student. So insert new, oh actually not insert, let's go ahead and simply say register new and then student. There we go. And inside you can say that this will take a student, or actually will receive a student. So student, just like that. For now, let's simply go ahead and simply say south and then student. Next, let's go ahead and define, so if I put this full screen, let's go ahead and define another method. So public and then void delete and then student, and this will take the actual integer ID. Oh, actually, let me name this as student and then ID, just like that. And for now, let's also define, actually print student ID. So we're not going to do any logic here because I just want to show you exactly how to secure your RESTful APIs. But if you want to learn all about this, go ahead and check my website for free courses where I teach all of this. So finally, let's go ahead and have a final method. So public and then void, and this will be update and then student. And obviously this will receive the actual student ID. So student ID and then the actual student. So this is the actual student to update, right? So there we go. Now let's go ahead and simply say south, and then right here we're going to print the student ID. So actually string dot format and %s and then %s and then student ID, and let's also pass student, just like that. So obviously now we need to actually define these as RESTful APIs, right? Because right now these are simply plain Java methods. So to tell Spring that this must be a GET request, right? You should be annotating this with @ and then GET mapping. Next, for registering a new student, this will be a post. So we are adding a new resource into our system. And then the way that we get the student from the request body is simply by annotating this with @ and then request and then body, just like that. Next, to delete a student, what we're going to do is simply say @ and then delete mapping, and inside what we're going to have is simply a path, and within the path what we're going to receive is the student and then ID, right? And the way that we map the path, so the actual student ID that comes from the path, is simply by saying @ and then path variable, and then this will be student ID, just like that. And we have to do the same for, so right here, so for update, so this will be @ and then put and then mapping, and we're going to receive the actual student ID right here. So let's just steal this. There we go. There we go. And right here, add, and then request body, and then student. And now we have an API that we can secure. And there we go. Next, let's go ahead and test this API with Postman. Alright, so before we test this, I've actually spotted that I didn't use student ID right here. So now let's go ahead and test this API. So go ahead and restart the application. And while that's up and running, let's go ahead and open up Postman. So right here for the request, so let's perform a GET request to localhost API and then v1 students. And right here, so this will be management API, remember, so right here, so management API v1 and then students. And for the authorization, let's use basic auth, that's what we are using. And let's use for now Anna, or actually let's use Linda, right, because this is for Linda and Tom. So Linda's password is 123. So now if I go ahead and send, you can see that we have all the students. So the same with Tom. So let me try with Tom. So Tom, and this is password, send, and it's unauthorized, and I think the password is the same as Linda. So send, and of course there we go. So now let's go ahead and try to post a new student. So right here, let's grab this JSON payload, and in the actual body, let's go ahead and say that this will be raw, and then this will be JSON. So right here, so let's actually get rid of that. So IDs should be generated by the actual server and not the client. So right here, let's simply go ahead and say Alex and then Gomez. So just let me tell you that this will fail, right? So go ahead and go ahead and try to send this request, and you can see that we have a 403 forbidden. Now we will learn how this is failing, and this is actually Spring Security doing the right thing, right? It's actually securing our API. So the same with, let's say, put, right? So if I go ahead and try and put, and then simply say 1 right here, because that expects 1. So let me show you. So right here, student management controller. So right here, so the actual, so if I put this full screen, so the put mapping right here requires the student ID and then the actual student, right? So right here, this is what I'm doing. If I send this, you can see that it's also forbidden. Now, as I said, I'm going to explain this in detail in the next section, but for now, go ahead and open up application security config, scroll up, and right here, so inside of the configure method, go ahead and say dot and then CSRF and then dot disable. And let me just add a to do here. So to do, and then I will teach this in detail in the next section, just like that. So now restart the server, and again, I'm going to explain this because this is really important and fundamental, and you must know exactly how this works. So for now, just ignore it at this line and go back to Postman, and let's try to send a put request. And now if I send, you can see that we have a 200 status code. Let's go ahead and try to delete. So delete will be the same, so delete and then 1. And let's go ahead, and we actually don't need to pass anything right here, so let's go ahead and simply say send 200 right here. And now let's cut, and finally let's go ahead and try to post, because that failed previously, and that will take Alex Gomez. So let's go ahead and simply say send and you can see that 200. So both post, delete, put, and get methods are working. Now let's go back to IntelliJ and watch the console. So right here, so you can see that we have one and then one, and basically this is not really intuitive. So what I'm going to do is actually add another system.out line, so south, and this will be the name of the method. So just like that, and let me grab that and then put it here. So delete. So I want you to see that this is actually working properly. And finally, this will be so south, and this is update. There we go. And this is actually get all students. So south, and then get that, and then paste that in. And also you can see that we have this random number right here. So go ahead and open up student, and inside let's go ahead and override it to string method, and actually not like that. So I'm going to press Control and then enter to string, and you can see that that selects all the variables that we have. Okay, and there we go. Now if I restart, and I'm going to open this up and go back to Postman, let's go ahead and perform a get request. So Tom is actually issuing the get request, send. You can see that's working. Let's go ahead and send a post. So I'm just selecting from this list, send. You can see 200. Let's go ahead and put 200, and finally delete. And there we go, 200. Now go back to IntelliJ, and you can see that we have get all students was invoked, and then register new student, and this was the actual payload. So see right here, ID null, and then student name Alex Gomez, and then update student. So we wanted to update Alex, which has the ID of 1, and then this was the actual payload right here. And then we wanted to delete the student with an ID of 1 right here. So obviously this is like a dummy API, but you get the idea. So as I said right here, so let me just actually mention it again. So this line right here, go ahead and add it, because Spring Security by default is trying to protect our API. But this you will learn in the next section. So just bear in mind that this is very important that you understand how it works, and I'm going to make it very easy for you to understand. So now that we have an API up and running, let's go ahead and implement the permission-based authentication. Alright, so let's go ahead and implement permission-based authentication. So Linda will have the ability to read and write, but Tom will only be able to read. So it means that in our API, so Student Management Controller, Tom will only have the ability to get all students. So registering a new student, deleting a new student, and updating a new student, only Linda can do it because she has the right permission right here. So to implement permission-based authentication, let's go ahead and open up application security config, and there are two ways that we can do it. So I'm going to show you using ant matchers, but then I'm going to show you also with some annotations in the actual methods, which is my preferred way. So right here, what you can do is simply say ant matcher. So we will add another ant matcher, and the actual pattern will be so management, and then /API / and then **. So what I want you to see right here, so we are actually saying / right here. So this is anything that starts with management /API and then anything. So inside of this ant matchers, we can have as the first argument an HTTP method. So right here, I can say that this will be a delete method, and then comma, And then right here, we have to say dot and has, and then authority. So this is the actual permission. Remember, I said that authority is pretty much the same as permission. So the permission that we want is application and then user permission dot, and then we want anyone that has course and then right, and this will be name. And let me actually have this as static import, and there we go. So we can go ahead and duplicate all of this. So this will be post, and this will be put. And then finally, what we're going to do is simply say dot and then and then matchers. And I'm going to grab this. So right here, I'm going to grab this and then put it here, actually within quotes, and then dot has, and then any role. And then the roles are application user role dot and then admin, or application user role dot and then admin trainee. So obviously we need get name here, or actually just name, and the same with admin dot and then name. And finally, we can also add the actual get method right here. So there we go. So as you can see, we now have these 4 matchers, and we are using has authorities instead of has roles. So currently, if we navigate to user detail service, so our users, they are role aware. So you can see that we are defining the roles right here. So roles, and roles. So they don't know anything about permissions or authorities, and that's what I'm going to teach you next. All right, so go ahead and click on roles. So roles, I'm going to press command and then go into roles. So inside of this builder right here, you can see that it builds a list of granted authorities. So the special thing here is that when we add the roles into this authorities right here, so this authorities, which is a list of granted authorities, you can see that this builder appends the role underscore, so role underscore, and then the actual role. So that's why if I go back, so right here, that's why I've mentioned that this will be role underscore and then student. The same with admin and the same with trainee. So this means that if I open up roles, so right here, so you can see that all we need is this simple granted authority right here. And for a role, so if we want to use role-based authentication, we pre-append the role underscore. If we want permissions, we simply pass the permission as is. So let me actually show you what I mean. So if I go back, and inside of this user details, you can see that this is an interface. So we will implement this interface in a second, but for now you can see that there is no concept of roles and permissions. So everything is bundled inside of this collection, so get authorities, and this has to extend granted authority. So anything that goes in here has to extend granted authority. And you can see that we have the password, username, and some other booleans right here, which I'm going to explain later on. So for now, let's go ahead and comment these lines. So right here, so roles, and then roles right here. So let's go ahead and simply say dot, and then you can see that we have authorities, right? So we can pass a string, the actual granted authority, or a collection. So just let me show you the actual implementation first. So right here, so granted authorities. So this granted authorities simply calls this granted authorities, and this is simply so basically it takes your collection, right, and then it builds a new array list. So it means that we have to build the roles ourselves. So let's go back and let's open. So we're going to open the application user permission. So right here, oh, actually, sorry, the application user role, and inside where we have the permission. So what we're going to do here is go ahead and simply say public and then set. And right here, let's go ahead and simply say granted and then authority. And I'm going to say get and then granted authorities. And now what I'm going to do here is simply say get permissions dot and then stream. And on a new line, I'm going to say dot map, and this will be the permission. And I'm going to map this to new and then granted authority. Oh, actually not granted authority. So let me just show you exactly. So granted authority is an interface, and you can see the actual implementation. So just granted authority, simple granted authority, and switch user granted authority. So let's implement this simple granted authority. So right here, new and then simple granted authority, and you can see that this takes a role. So right here, let's simply go ahead and say permission. And finally, simply say dot and then collect is to set. And right here, we have to say dot and then get permission. So this is the actual string. So get permission, remember, is this bit right here, which is this. So let me go back and put this full screen. Now let's go ahead and simply extract this to a variable and simply say permissions. And what I'm going to do here is simply say permissions dot and then add new and then simple granted authority. And right here, I'm going to say role underscore and then plus, and guess what? This dot and then name. So this is the actual role. So let me end that with semicolon, and finally simply return and then permissions. And we have an error, and this is saying that we actually returning the wrong type. So obviously, so this should be simple granted authority, just like that. So now let's go back to application security config, and now right here inside where we say authorities, we can simply say, so let's go ahead and say student and then dot and then get granted authorities, and you can see that this works. So now let's do the same with Linda user. So dot and then authorities, and then this will be admin dot and then get granted authorities. And let's do the same with Tom. So authorities, or actually dot and then authorities, and then admin trainee dot get granted authorities. So what I'm going to do now is, before we actually test this, let me actually add a breakpoint right here, because I want you to see exactly what I'm doing. So what I'm going to do is simply stop the server, and I'm going to debug this. So there we go. So I had previously a breakpoint here and there. Let me just remove those, and also right here, continue, and there we go. So now I want you to see this. So actually I can show you right here. So if I expand this, and you can see that we have Anna Smith, Linda, and Tom. So let's actually look at these values. So right here, so you can see that we have the password, username, and then authorities. You can see that we have the role. So remember, so Anna, she's a student, she doesn't have any permissions, remember. So right here you can see that she only has one role, and it's role underscore student. So next, let's look at Linda. So she has 5 authorities, and you can see that the authorities are role admin. So she's an admin, and then she has the set of permissions. So course read, write, student read, and student write. So the same for Tom. So let's look at Tom. Tom has 3 authorities, and this is the actual role. So role underscore admin trainee, and then 2 permissions. So course read and student read. So there we go. So now we have attached the correct authorities to our users, and now we are good to go to use permission-based authentication. Let's go ahead next, test these and matches right here that we defined previously. All right, let's go ahead and test these and matchers. So these and matchers are for this diagram. So Linda has access for reading and writing, whereas Tom can only read. And the only API that Tom can access is anything that has this pattern, and it must be a get method. Also right here where we have has authorities, so this should be get and then permission. So right here, get permission. So get permission right there. And for roles should be the actual name, right? So we could actually say, get role to follow the same pattern, but you get the point. So now let's go ahead and restart the server. And let's go ahead and test things out. So Tom, so remember, Tom is only able to read, and Linda can perform all the operations inside of our API. So Tom, let's go ahead and send a get request. There we go. You can see that works. Let's change this to Linda. Send. It also works. Now with Linda, let's go ahead and send a post request. Inside of the body, add anything. So student name and then whatever name you want to add. So in my case, Alex Gomez, and then send. You can see that we have a 200. Let's go ahead and delete. So delete and then any number. So delete and then send. You can see that works. And finally, let's go ahead and update. So put and then send. You can see that also works. Now let's go ahead to authorization and change from Linda to Tom. So let's start with post. So post and then body, make sure you send a payload, send, and ta-da, you can see that. So right here, the request was forbidden. Let's also try put, send. You can see that it's forbidden. And let's finally try to delete. There we go. And then send. And you can see that all of them were forbidden apart from fetching students. And we've managed to achieve all of this. So hopefully now you can see the power of Spring Security and what it can do for you. So if you have any questions of what we did with permission-based authentication, go ahead and drop me a message. Next, I want to teach you something really important. So right here. So I want to teach you something important to do with the way that these matches are processed. Alright, so before we move on to the next section, I just want to talk to you exactly how you should be defining these AND matchers. Now, right here, so you can see that I'm defining these matchers, and the order that I define these matches and the actual order that I define these matches does really matter. So as it stands, I could actually do this. So right here, I could remove get, and basically if I restart the server and go to Postman, so Tom, let's go ahead and try to delete, send. You can see that it's forbidden. Now, the reason why I don't need to add the get method here is because it goes through the matches one by one. So, Tom, can you access any of these? Yes. Are you a student accessing the API? No. Are you accessing the manage API? Yes. Do you have course write permission? No. And then it blocks it immediately. So right here, you can see that if I take this line and then put it right here. So let me put it right here. So right here, you can see that this is the first thing that happens. Now, if I restart the server and then go back and then send the request, you can see that now we have a 200, right? So this means that the order that we add these matches does really matter, and you have to be really careful when defining these matches. So really what I want to stress out in this video is that the order that you define these ANT matches does matter. Next, let's go ahead and learn how we're going to have the same role-based authentication but with annotations inside of these methods right here. So the same way that we have at get mapping, we can also have an annotation that will secure this specific method. So to use permission-based authentication on a method level with annotations, we have to use this annotation right here, at, and then pre, and then authorize right here. So this pre-authorized takes a string, and right here we can say things such as has role, has any role, has authority, and has any authority. So let me actually write these down for you. So right here. So there we go. So has role, has any role, has authority, and has any authority. So let's go ahead right here and simply say has and then role. So basically right here, remember, so right here we have, so if I put this full screen, so we have for the actual get method, so has any role. So right here, so as, or actually any, and then role, and then we have to pass the actual roles. So role and then admin, comma, role, and then admin, and then trainee, just like that. So for the registering new student right here, let's go ahead and simply say at, and then pre-authorized, and then inside, so let's go ahead and say has, and then authority, and then this will be, so guess what, student, and then right. So let's actually copy this. So I'm going to copy student right, and then, or actually I'm going to copy this entire line because this will be the same for the delete mapping and the same for put mapping right here. And basically we are now replacing all of these. So all of these four ANT matches, so these ones right here, so all of these four with annotations. So I'm going to comment this out and I'm going to leave it here so that you can refer to it whenever you need it. Now we have these annotations right here at pre-authorized with has authority, and right here with has any role. And in fact, I'm missing actually some quotes right here, so single quotes on either side like that. So this is like an array, so one element and then the second element. So we have these annotations right here, so pre-authorized with some conditions inside, but we have to tell our configuration that we want to use these annotations for permission or role-based authentication. So the way we do it is inside of the configuration, so application security config, go to the very top right here, and we need to say add and then enable global method security, and then inside right here simply say pre and then post enabled, and you can see that the default is false, and we're going to toggle that to true. Now let's go ahead and start our server. There we go, up and running. So let's actually test the same API with Tom and Linda. So remember Tom, so let's go ahead and try and get, so everyone. So Tom should be able to get all students. So if I send, there we go, indeed it's working. Now let's go ahead and try to add a new student. Send, you can see forbidden. Let's go ahead and delete. So we have to have / and then a number there. Send, forbidden, and finally put. So put, send, and make sure you have a payload right here. And you can see that all three methods, so post, delete, and put, fail for Tom. Now let's change this from Tom to Linda. So Linda, let's try to send a put request. You can see that works, so 200. Let's go ahead and try and send a delete. There we go, you can see 200. And finally, let's go ahead and try and send a post. So without 2 there, send, and you can see that it's working right here. So we have some logging right here, and you can see that it is working for Linda. And this is how we use @preauthorized to control what roles or permissions can access your resources. So I'll leave up to you to decide which one you prefer, but there are scenarios where pre-authorized might be more sensible, or by defining these ANT matches right here. So if you have any questions on this, go ahead and drop me a message. Otherwise, let's move on to another topic. Alright, let's go ahead and tackle this to-do right here, which I had previously. So I said that I was going to teach you in detail what this means. So CSRF.disable, but in general, what CSRF is. So CSRF stands for cross-site request forgery. And forgery means an action of forging a copy or imitation of a document, signature, banknote, or whatever it might be. So in this example right here, we have an attacker, and this attacker wants to forge a request to take money from this user right here. So this logged in user, which is using his internet banking, for example. So the attacker wants to take money from the logged in user into his account. So the way it works is that the attacker forges a request, and inside of that request, it embeds a request into a hyperlink. So this is, for example, a link that if someone clicks on it, it sends money from the logged in user into the attacker. If the attacker manages to send this logged in user into a malicious website, then the logged in user is in real trouble, because when the logged in user clicks on the link embedded by the attacker, then it pretty much just sends the request into the real server that takes money from the logged in user into this attacker's bank account details. So the way that Spring Security protects us from this kind of attack is by enabling cross-site request forgery, which we have disabled right here. So when it's enabled, what happens is this. So the front end, right? So this is the client, right? So the client, so when the client logs in into our server, Spring Security sends a cross-site request forgery token into a cookie. And then the front end uses that token for any form submission. So form submissions usually are post, put, or delete. And then the server validates that token to see whether it matches what the server had sent previously. So when CSRF token is enabled, there is no way for this attacker right here to know what was the original token that the server had generated for a particular client. And with this, problem solved. So let me go back to IntelliJ and right here. So let's comment this line out, right? So we're going to enable cross-site request forgery. So if I restart the server, there we go. And if I open a Postman, so right here, so remember before Linda was able to post requests. So if I now try and let's actually first send a GET request. So let's send a GET request. There we go. So you can see that this works. But now if I go ahead and send a post request and inside of the body, so let me actually grab this student and this will be raw and then JSON right here. So that will be empty. So if I now try and send this payload right here, so I'm going to send this payload, you can see that Linda, she's forbidden from performing this request. So Spring Boot Security is doing its work. So basically, so right here, so the client is logged in with basic auth, then the server sends the actual CSRF token, right? So we actually haven't got this part yet, but I'm going to show you exactly how to do it. But now when the front end sends the actual form, i.e. post, put, or delete, this bit kicks in. So the validation kicks in, and because we haven't sent any token, the request is rejected. So if I go back to IntelliJ and let me uncomment this again and restart the server, there we go. Now if I send the request again, you can see that now we get a status code of 200. Now it works. So when should you enable cross-site request forgery? So on the actual official documentation, it says that the recommendation is to use CSRF protection for any request that could be processed by a browser by normal users. So if you are only creating a service which is used by non-browser clients, you likely want to disable cross-site request forgery, which is what we have done with this line right here. So in fact, I can uncomment this or actually remove this to do because we are learning about this. So next, let's go ahead and learn exactly how to send the actual token. So this token right here. So right here. So when the client logs in, how do we see this token right here so that the client can use it to send it back to our server? All right, let's go ahead and learn how to generate this token to our front end. So what we need to do first is to actually enable cross-site request forgery. So right here, what I'm going to do for now is simply delete this line. We're going to add it because we need to configure this. But for now, just go ahead and delete that line because I want to show you something first. And also, let's go ahead and delete all of these ANT matches because we are using annotations. And you can also get the source code from the previous branch. Now, go ahead and restart the server. And go to Postman And right here, let's go ahead and send a GET request. So Linda, she's accessing management API, and you can see the password is password123. Now, let me go ahead and send this request, and you can see that we have a 200 status code. So this is fine. So if you are using Postman like me, go ahead and click on this icon, which is the Postman Interceptor. So I'm going to click on it and then simply enable. And basically this allows us to use browser cookies and use all headers inside of Postman. So let me go ahead and install. And I'm going to add it to Chrome. There we go. Now, if I go back, I think it should have installed. There we go. So this is now installed. So if I send the request again and then go to cookies, so you can see that now we have some cookies. So let me actually remove it. So send. Oops, I think what we need to do is actually let me clear everything. So let me clear those requests and this one as well. So I just want you to see exactly what I'm doing. So let me clear everything. So don't save, and this will be localhost and then management. And if I send, you can see that we have 0 cookies, right? But as soon as we enable this interceptor, and now let's go ahead and send the same request, now we have some cookies. And I'm going to grab the actual token right here. So this is the token. So I want to press Command C. And then now let's go ahead and send a post request. So post, and then in the actual body. So right here. So let me scroll up. So in the actual body right here, go ahead and simply say raw. And then this will be JSON. And right here, student and then name, and Alex and then Gomez. And now go ahead and navigate to headers and go ahead and add the following. So X, well, actually all caps, so X and then dash XSRF dash and then token. So this is the actual header that Spring Security is expecting. So actually, let me go ahead and just send this request as is. So if I send the request, you can see that we get forbidden. Now, if I add the header and then paste the actual token, so this was the token. And now if I send, you can see that we have a 200. And this is cross-site request forgery with Spring Security. So obviously we are passing the actual token right here within Postman, but this, for example, if you are using React or Angular, you need to implement the logic to get the actual token from the header as we did right here. So remember, if I send the GET request and then cookies, you can see that you can grab the header. So XSRF token, and then when you perform the actual post request, you simply pass it, and then you pass the actual token. Next, let's go ahead and learn how this token is actually generated within Spring Security. All right, let's go ahead and learn how these tokens are generated. So let's go back to IntelliJ, and right here, let me actually revert the cross-site request forgery.disable. And now what I'm going to do is actually remove that, and we're going to configure it. So with cross-site request forgery, there is a method called CSRF token repository. So go ahead and select it, and then inside I'm going to say cookies CSRF token repository with HTTP only false. And then right here, I'm going to say dot and then and. So right here, this is simply configuring how we are. So right here, this is simply setting up the actual repository. So how the tokens are generated. So by default, Spring Security is doing that for us. but we can add some extra settings. So right here, you can see that we are passing with HTTP only false. So what this line right here means, it means that the cookie will be inaccessible to client-side scripts. So if the client tries to access the cookies with some JavaScript, then it won't be able to do so. Now, if I go back, let me just go back and let me collapse this. So go ahead and click on Cookies CRF Token Repository. And I just want you to see the actual implementation. So right here, simply scroll down and you can see that this is the actual header. So this is what we have defined right here. So this is the actual header, remember? So right here, if I scroll down, you can see that you have a save token, right? Which generates a brand new token and then creates a cookie, sets the security, and then, sets the path. And you can see that it's setting like the max age. And right here, it simply adds a cookie to the actual response, right? So this is this bit right here. So we are getting the actual cookie right here because of this implementation. The same with load token. It loads the cookie if there is any. And you've got some other methods right here. So basically, go ahead and read this class to get a full understanding of how this works. And finally, another class that I want to show you is this one. So go ahead and press Command N and then search for CSRF and then filter. So this one from Spring Framework Security. So the very first one. So go ahead and click on it. And basically right here, so this class right here, it's a filter that runs. So if I scroll up, it runs once per request. So basically you can see that there is this filter called do filter internally. And right here, you can see that the implementation is very simple. So it sets some attributes, then it tries to grab the token, right? So this is grabbing the token. And then if it's missing, it generates a brand new token and then saves it to the repository. And then right here, it checks whether we need to actually check the token based on the request, i.e. if the request is a post, put, or delete. If so, then we actually try to get the actual token right here. And then we compare the tokens, right? And then right here, you can see that if the token is missing, we get access denied. And also if the tokens are not the same, you can see that we have invalid token found. And this is all for this video. So if you have any questions, go ahead and drop me a message. Otherwise, let's move on. All right, by now you should know how the cross-site request filter works, right? And also how the token repository is implemented. So I think that now you have a clear understanding of what is cross-site request forgery. And also you should know when to use it, right? So let me actually remind you. So the recommendation is to use this protection for any request that could be processed by a browser by normal users. If you are only creating a service that is used by non-browsers clients, then you likely want to disable it. And that's what I'm going to do because I'm using Postman and this is not relevant to me. But obviously, if I'm submitting forms from any client to my server, I will definitely use this. And you now know how to use it. But throughout this course, I'm going to be using Postman. And because I don't want to generate this token or actually, pass the token inside of my headers all the time because this changes, I'm going to simply disable it. Right, so I'm gonna comment this and that as well, and then cross-site request, or actually dot, and then cross-site request forgery dot, and then disable. So as I said, if you have any questions, go ahead and drop me a message and I'll be more than happy to assist. So far throughout this course, we've been using Basic Auth. And just to recap once more what Basic Auth means. So with basic authentication, we have to include the authorization header in every single request. If you are planning on using this, HTTPS is recommended. And to be honest, Basic Auth is really simple and very fast. So one of the disadvantages of Basic Auth is that you cannot log out. So right here, so this is what we've been doing throughout this course, where the client sends a request, it might receive a 401 saying unauthorized, and what the client does, it simply attaches the authorization in the header, and then it sends the username and password as base64, and then if the server recognizes those credentials, it just sends a 200 status code with whatever the client has requested for. So in this section, let's go ahead and switch from basic authentication to form-based authentication. So right here, so let me make this smaller. So with form-based authentication, as I've mentioned before, so this is widely used throughout the internet, and this is what you tend to see all over the shop, where you have to specify the username and password. It's the standard in most websites. It uses forms, and the cool thing here is that you have full control on how you want to style your form. And you can log out, that's a good thing. And also HTTPS is recommended. So the way it works is the client sends a post request with username and password. The server validates those credentials, and then it sends a 200 status code along with a cookie. So in this cookie, the session ID is attached to the response. And then any subsequent request from the client doesn't have to send the username and password, but it sends the actual session ID. And then for each request, the server validates whether the session ID is still valid. If I'm not mistaken, the session ID is valid for about 30 minutes. And then if everything is fine, then the server sends a 200 status code with whatever the client has requested. So let's go ahead and switch from basic authentication, so basic authentication, to form-based authentication. Alright, so before we switch from basic authentication to form-based authentication, let me go ahead and show you once more what basic auth looks like. So let me go ahead and open up Chrome. And right here, go ahead and simply try to access management and then API and then V1 and then students and then enter. And now you can see that we get this pop-up where we have to specify the credentials. So Linda and then password. And what was the password again for Linda? So Linda was password 123. So password 123, sign in, and there we go. So now we get this JSON array right here. Now let's go ahead and switch from basic authentication to form-based authentication. And right here, so instead of saying and then HTTP basic, what we're going to do is simply say and then form login. And it's that simple. Now, you might have seen this at the very beginning of this course, but at that time, I didn't actually explain to you what form-based authentication was. So let me go ahead and restart the server. There we go. If I go back to Chrome, and now if I refresh this page, and there we go. So you can see that form-based authentication has kicked in. Now let me go ahead and simply say Linda and then password. Or actually, let's use Anna Smith. So Anna Smith. So she is a student, Anna, and then Smith. And right here, the password is password. So let's just confirm again. So Anna Smith right here, and the password is password. Now, if I sign in, you can see that we are getting a forbidden because she can't access the management API because she's a student. So that's a good thing. Let me remove that. And then API v1 students. And then here she can access, for example, 3, enter. And you can see that she's getting her account details. So student name, Anna Smith. So there we go. This is how you enable form-based authentication. Next, let me go ahead and show you this part right here. So we actually have the credentials validated by Spring Security. Next, let me go ahead and show you where you can find this cookie right here with the session ID, because now I can go ahead and simply perform another request. So 1 and then enter, and you can see that it's working. I don't have to specify the username and password again. So let me go ahead and show you exactly where this session ID is. All right, so I'm using Chrome, and this should be the exact same process if you're using, for example, Safari, Opera, or any other web browser. So currently we are logged in into our system. So I can refresh this page and you can see that I'm authenticated. Now, what I'm going to do is right click and then go to inspect. And then right here, I'm going to go to application. So what I want you to see is within applications, you have this storage section right here, and then you have cookies. And you can see that I've got the cookies for my application, localhost 8080. So right here, so what I want to show you is what we have in here. So basically, you can see that we have a cookie, JSession ID, and then this is the actual value, right? So this is the value for our session. And as I mentioned before, the default expiration time for this session is about 30 minutes. So the way this session works, if I go back to the actual diagram, so I've mentioned before, so we actually perform the post request, passing the username and password, the server validates the credentials, sends a 200 status code, including the actual session ID right here. So this session ID, right? So the session ID is stored in some kind of a database right here. So what I'm going to do now is actually go to IntelliJ and then restart the server. And there we go. Now if I go back, so remember before this session ID right here ended in 3AF0. Now if I refresh the web browser, you can see that I've lost my session, right? And this is because, so right here, so this is actually using an in-memory database. So by default, Spring Security uses an in-memory database. But obviously, we can use, for example, post and ingress, or, so if I scroll down, or Redis. So these are some of the options. So let me just add like that so you can see exactly. So by default, Spring Security uses an in-memory database. And you've just saw that I've sent the same token right here. So the same token. And then because the server restarted, it lost all the session IDs. So usually it's best practice to store your sessions in a real database, something like Postgres or Redis. So right here, let me go ahead and simply log in again. So Anna and then Smith and then password, sign in, and there we go. So there we go. So I just wanted to show you exactly how session IDs work. And if you have any questions, go ahead and drop me a message. But I'm going to leave you some documentation on how you can implement session IDs against a real database such as Postgres or Redis. This is all for now. Catch me on the next one. Let's go ahead and learn how we're going to be able to override this form right here. So sometimes you want to customize this form yourself, changing the style, including more fields, so on and so forth. So go back to IntelliJ, and what we need to do here is, so we're going to say after form login, go ahead and simply say dot and then login page. And right here, go ahead and simply say / and then login. So I'm going to restart the server, go back and then restart, or actually refresh, and you can see that the page isn't working. So what we need to do is go back to IntelliJ and open up the pom.xml, and right here let's go ahead and add a new dependency. So I'm going to add a new dependency right here, so dependency, and then this will be time, or actually just like that, so time leaf, and this will be org.Spring Boot framework. So basically TimeLeaf is a templating engine which allows you to do many things in regards to HTML files. So now that we have this dependency, go ahead and inside of resources, go ahead and create a new folder, so directory, and right here simply name it as templates. So make sure it's actually templates with an S. And then inside of templates, go ahead and create a new file, and then simply say login.html. And for now, let's go ahead and simply say h1, and right here login and then page. And now inside of our main package, so com.example.demo, go ahead and create a new package, call it controller, and inside let's go ahead and create a class, and right here let's simply go ahead and say template and then controller. Now actually I need to fix this typo, so it should be controller, so I'm missing an R there. And now let's go ahead and annotate this class with @ and then request mapping, and this will be /, and right here go ahead and simply say @ and then controller. So we're going to annotate this class with @ controller. Now let's go ahead and say public, so we will create a new method, and right here we're going to say string, and let's go ahead and simply say get and then login, and then view, and inside right here let's simply return and then login. So basically this login has to be the exact same name as the one we have inside of templates, but without .html. Now right here simply annotate this with @ and then get mapping, and there we go. Let me restart the server. There we go. Now if I go back to my web browser and then refresh, and it's not working, so let's go back to IntelliJ, and right here, so inside of the get mapping we need to say that this will be login, right? So we're not mapping login to anything. Now let me restart the server again. There we go. And if I refresh now, and still not working, so what I think is happening is that we are getting blocked by Spring Security. So let's go ahead and open up the application security config, and right here, so inside of our configure method, so there is no way that we are permitting any requests to / login. So let's go ahead and simply say dot here and then permit and then all, and that with semicolon. And if I restart the server now, so hopefully fingers crossed this should work.